Hello everybody, it's Miss Moran again, back with this week's lesson on multiples and prime and composite numbers. This is related to what we learned about last week when we talked about factors. So the importance of what we're doing this week is that students are able to describe how multiples are related to multiplication. Seems kind of obvious, but within the word multiple is the word multiply. So last week we learned about factors. Factors would be the facts that are multiplied. So if 3 times 5 are our facts, the answer or the product of that multiplication problem becomes a multiple. So 15 is a multiple of the factors 3 and 5. We have 2 strategies that we want students to be able to use when it comes to listing out the multiples of numbers. One would be a simplistic way, which is to do your skip counts. So if I could do my skip counts of 3, that starts at 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. I'm going to list a little ... there that shows that these actually do continue. I don't have to write them all out, but those numbers of skip counts of 3 would continue on into infinity. If I also wanted to look at the number 5, I can list the skip counts of 5 as well. 5, 10, 15, 20, 25, 30, and so on. So as I notice, if these numbers are my factors, 3 and 5, I notice that as they skip count out, we would land on 15, just like this. And as this 5 skip counts out, we would also land on 15. So we can use skip counts as a way to find the answer to multiplication problems. Another strategy we would want to use, and I'll use 4 here, is if I ask you to list the multiples of 4. You could skip count it like we've done here, but another strategy is to understand that the multiples are the answers you get when you multiply factors together. So if I wanted to list out 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, and so on, the answers that I'm going to get to these multiplication problems is going to be my multiples. So 4, 8, 12, 16, and 20. These would be my factors, what we learned about last week. This would be my multiples. Okay, again, so 2 ways of doing this. One, listing out your skip counts, and another one by actually multiplying out these numbers. Another thing that students are going to be expected to be able to do is to be given a number, like for example, 27. Is 27 a multiple of any given number? So we'll go with 3. Okay, is 27 a multiple of 3? Well, in order to answer that, I would want to either list out my skip counts of 3, which I have up here, and I can find that. It's listed in this list. And another thing we'd want to be able to do is to see if we can prove it with a number sentence. Can I do 3 times some number to equal 27? I know my facts. I know 3 times 9 is 27, so I'd say that yes, 27 would be a multiple of 3. If I wanted to look at 5, is 27 a multiple of 5? When I skip count out my 5s, am I going to see 27 in my list? No, I'm not. It skips over it as it goes from 25 to 30. Can I write a number sentence? 5 times some number that equals 27. I know 5 times 5 is 25. 5 times 6 is 30. There is no way for me to multiply 5 times some number to equal 27. So I'd say 27 is not a multiple of 5. One last strategy and skill we'd expect them to be able to do is related to what we did last week also. We talked about common factors. Well, we also have something called common multiples. When I look at my sets of 2 numbers, I want to see if any of them have common numbers. Are there any numbers that when I skip count my 5s, I would land on the same numbers if I skip count my 3s? So when I look here, I see that 15 is going to be a common multiple of both 3 and 5. 30 is going to be another common multiple of both 3 and 5. And these are just 2 common multiples. As we said before, these numbers can continue on forever, so if you continued your list, you would find a lot more. Okay, in fact, you would find them every time you win another 15 numbers. Okay, so that's it for multiples. Again, students understand how factors are related to multiples, that factors are the numbers that get multiplied, multiples are the answer or the products to that multiplication problem. Okay, another thing we're going to be working with later this week is prime and composite numbers, which is really not a new skill. It's just new vocabulary that goes along with something we've already been working with all week, which is related to factors. A prime number is any number that has only 2 factors. And the only two factors that it has is 1 times itself. That is the only way to multiply and get that number. A composite number is any number that has more than 2 factors. Okay, that can be 3 factors or 4 factors or 5 factors or 6 factors. It has 1 times itself, and it has some other way to multiply other than just 1 times itself. And I'll give you a few examples of those kind of numbers. Let's take a look at the number 12. Okay, so for 12, I'm going to list out my factor pairs, and I'm looking to see that I have either only 2 factors or more than 2 factors. So with 12, I can do 1 times 12. I could do 2 times 6, and 3 times 4. Okay, so how many factors do I have there? 3 factor pairs, that's 1, 2, 3, 4, 5, 6 factors. So this would most definitely be a composite number. Okay, the number 7. I can multiply 1 times 7, as we can always multiply a 1 number, or 1 times itself. And I think about my other numbers. Can I do 2? 7's an odd number, so I cannot do 2 times some number to equal 7. 3, if I did 3 times 2 would be 6, and 3 times 3 would be 9. That doesn't work. 4 times 2 is already too big at 8, so that's all. My only 2 factors are 1 and 7. When I have only 2 factors, 1 times itself, then that will be a prime number. Okay, so we're using factors, but you need not actually be able to list every single factor to prove if a number is a prime number. We're working with numbers all the way up to 100, and we want students to be able to tell us if they are prime or composite. So when I look at 68, obviously we know we can do 1 times 68, but I want students to recognize that because this is an even number, we know that it's going to have a factor of 2. All even numbers have a factor of 2. So 2 times some number. Now, it's not important to me that a student can actually figure out what this partner fact is, as long as they know that there is some other fact. Because again, in order to be composite, you don't have to list all the factors, you just have to know that there are more than 2 of them. So 2 times some number, there are plenty more here, 4 would be another one, lots of other factors here. So this would be a composite number. And again, I know that just by knowing that it's even, and because it's even, I know it cannot have only 1 times 68. Another example of that might be a number like 85. Okay, big number. We may not know all the facts of that number, but I should know, in addition to 1 times 85, it's not an even number, so 2 is not going to be a factor, but I do notice that it ends in a 5, and we've been practicing how numbers that end in 5 will always have 5 as one of their factors. So 5 times some number. Again, I don't need to skip count my 5s. I don't need to try to do a division problem or try to guess and check my multiplication to figure out what that partner fact is. I know that it is something other than 1 times itself, and so I can go ahead and list that as a composite number. Okay, now we'll take a look at 9, because 9 is one that students start to see a pattern. They start to notice, okay, well, even numbers are composite. They often think that odd numbers are prime, but just because it's odd doesn't mean that there aren't ways to multiply to make that number. So we can do 1 times 9. We can also do 3 times 3, which gives me 1, 3, and 9. That's 3 factors. So if it has 3 factors, then it counts as composite because it has more than 2. Okay, prime numbers, only 2. So this is also going to be a composite number. Now, be careful about thinking that every even number is composite, because I have one exception, and that is the number 2. Okay, 2 is the only even number that is prime. Because of its size, the only way to multiply to get 2 is 1 times 2. Okay, there are only 2 factors. So even though it is even, it is the only number that is both prime and even. Little trick to remember. And then I have one other number to discuss, the lovely number 1, whose only factors are 1 times itself, 1. But how many factors is that actually? It's 1 factor pair, but there really is only 1 single factor. So, is it prime or is it composite? Well, a prime number has only 2 factors. A composite has more than 2 factors. So 1 does not have either one of those. So it is neither prime nor composite. All right, and that's all we're going to need to know for our test this week on Friday. Factors, multiples, and prime and composite numbers. Thank you so much for watching, and go ahead and like and comment if you'd like. Thank you.